Let's go on page 52. So started off with just, this is the function, and that's just it on the front, because I wanted you to be able to see everything. So on the inside here, here's your original function. And then I made the tables like with extra little columns again, because one of the things that you have to get from this is when you look at this, whether it's written in this form with this random thing, or we'll look at it a little bit differently when it's a parent function, you have to make sure that you understand what is changing X or Y. So even though some of these transformations you've done, I know you've done most of these, probably all of these, but you want to make sure that you can think about them in certain manners. So when I have f of x and f of x plus 3, what happens to that? It translates up, right? And up, how many? 3, right? So what's changing, X or Y? Y. Okay, so X stays the same. Y becomes Y plus 3. Is that a pretty easy thing to do? Yes? Okay, so instead of 2, we now have what? Instead of 2 for Y, it's 5. Instead of 0, it's 3. Instead of negative 2, it's 1. Instead of 0, it's 3. Instead of 2, it's 5. Instead of 4, it's 7. Instead of 0, 3. Negative 4, negative 1. All right? So we change them because what's changing here is Y. This is a vertical shift. So it's a vertical shift, right? So then we just get to plot these. We go to negative 6, 2, 4, 6. Stop me if I lose you or if you're confused, but I kind of feel like you're fine on this stuff. Okay. Now, I know that you could just take the points that you have and then count up 3 and redo them. That's fine. But, you know, sometimes things get a little bit more complicated, so you want to make sure that you can understand it from this perspective. Okay. Are we all good with that? Yeah. Okay. All right, so when we have this, f of x minus 2, then what's happening here? The x is changing. And so do we take x and we subtract 2? No. When something's happening with the x, right? So when x changes, you do what? Yes. So basically you do the opposite. And if you know that if it's always the opposite, whether it's like an adding or a subtracting or even multiplying, it becomes dividing and so forth, when the x changes, you do the opposite. So this is a horizontal shift, but is it to the left or to the right? To the right. So really, your x values become x plus 2 values, not x minus 2 values, right? Your y's stay the same. We're changing the x's. So negative 6 plus 2 is what? Negative 4. Good job. I know, it's a really hard question. Okay, negative 5 becomes negative 3, then negative 2, 0, 2, 4, 6, 8. Okay, everybody okay with that? That should totally be a review. No biggie, right? So now we can go over here and plot our points. So we go to negative 4, 2, negative 3, 0, 2, 4, 6, 8. Okay, everybody okay with that? That should totally be a review. No biggie, right? So now we can go over here and plot our points. So we go to negative 2, 3, 0, 2, 4, 6, 8. 2, 3, 0, 2, 4, 6, 8. 2, 3, 0, 2, 4, 6, 8. Just know when the x is changing, it is the opposite. Okay, everybody good? Yes? We can do that, no big deal. All right, I'm going to take that as a yes. Okay, so now we have f of x minus 2 plus 3. So what's changing here? Okay, is the x changing? Yes. Is the y changing? Yes. Okay, so for all my x values, what am I going to do to them? Add 2. So this is going to be x plus 2 and y plus 3. Because the y, you do what it is, the x, you do the opposite, right? So we can just fill in that chart then. They don't affect each other, you just have to do them both. Okay. Everybody okay with that? So you can fill in the chart and go ahead and graph them. All right. Everybody okay with that? Because now we have shifted up 3 and to the right 2. Okay. Total review, I didn't feel like we needed forever on translations. There's a little bit less to it. So that's when we're looking at just this, a table of values that you're given in some random function that just doesn't necessarily mean anything. But we also need to be able to look at this from a parent function perspective. So if you have this, what is this the graph of? What's the parent function? Square root, okay? So in this case right here, if I have this, and then I said, all right, well, if I have this, then if f of x is equal to the square root of x, then how can I write what's happening in function notation? This would be f of what? How do I make that? Because this is my parent function, and now this is happening. Isn't this just f of x plus 3? Right? So g of x, that's what g of x equals, right? Just different ways to look at it. So if this is my parent function, this is this notation, this is this notation. We good? Okay, so if I'm going to look at this, and we're going to look at this table as, you know, this right here being f of x. So you need some key points, right? We just need our key points, our important ones. So if you do a square root function, the good ones to use are 0, 1, and what? 4, and 9, right? Since we're taking a square root. We don't have to go any higher than that because it can't do it on the graph anyway. So if I plug this in for f of x right here, then this is 0, 1, 2, and 3, right? That means then on this case right here, what is changing? X or y? X, all right? So if this is what I have, right, you can graph your original one if you want to, if it helps you, but you should at least know what the, you know, even if it's just a little quick one, like you know what it looks like, right? It's supposed to look like that. So you just have an idea of what's happening. So then this right here, what I really need to do is x what? Minus 3. So this becomes negative 3. This becomes negative 2. This becomes 1. This becomes negative, oh no, this becomes 6. And I realize you might think, well, in this case, I wouldn't even need to do that because I can do it without it, and that's fine. But you also need to make sure that when it gets more difficult that you could do it as a table if you needed to wrap your mind around what's really happening. Okay? So now when we go to graph it, we're going to go to -3, -2. No, I'm not. -3, 0. Sorry, I keep doing that. -2, 1. Then 1, 2, and 6, 3. There's what it looks like. So got to have some key points graph, not just some random curve that you just slopped on that. Okay? Everybody okay with that? All right. Let's look at this next one. So if this is h of x, what's my parent function? If I want to call that f of x. That's just 1 over x squared, right? So that means that h of x is equal to, what's changing here, x or y? Y. So this is just f of x plus 3. Okay, so two different ways to look at this. Make sure you understand both and what it's asking you to do. Like if I had 1 over x minus 3 squared, yes, then the x is changing. Yes. Okay. All right, so quick little graph. 1 over x squared looks like this, right? Now, if you have asymptotes, your asymptotes change too. Like, do they shift and do this stuff like it's happening with the rest? They do, right? So we got to think about right where they are. Right now I have an asymptote on the x equals 0 and y equals 0, right? So let's do a couple of key points here. We can do, let's see, we'll do -2, -1, -1/2, 0, 1/2, 1, 2. Should be enough. From whatever the, like when I have the square root function and I know that it looks like this, then me picking -x's means nothing, right? It's just not even necessary. So here, I mean, you could do bigger ones, but if I know I'm going to square it, then I might not have room on my graph. They just kind of depend on your parent functions, just kind of something you'll learn from looking at them and just knowing what makes sense. And if you pick some and they don't, you're like, this isn't helping me, pick some different ones. You go by what you know about the shape of the graph. All right, so if this is f of x, right? So 1 over -2 squared would be what? 1/4, right? Then -1 squared is 1, so it's just 1, right? -1/2 squared is 1/4, so this becomes 4. And then this just doesn't even exist, right? So what's 1/2? What's the y? 4, and then 1, and then 1/4, okay? So these are your key points anytime you have the squared, the inverse square function. But we're changing y, right? So y becomes, since this is y plus 3, do I do y minus 3? No, this is y plus 3. So this is 3 1/4. This is 4. This is 7. What is this? Nothing, right? And then then 4 becomes 7, and then 4, and then 3 1/4. So what happens to your asymptotes? You add 2 of them. Do they both change? No. Which one changes? The x-axis. Okay, it was on the x-axis. We have shifted up 3, so your asymptote is now where? At 3. So here's your asymptote, right? Then when you go to graph this stuff, you aren't using these anymore because we've changed them, right? So we've got -2. You can go to 3 1/4. Oh, shoot. No wonder. I was using that as an axis. I was like, why is this not working? -2, 3 1/4 is right there. And then -1, 4, -1/2, 7, And then same thing happens over here. So this is what your graph looks like. Just be mindful of your asymptotes. Everybody good? Any questions? Any one of those that you think you may not know how to transform? We've got a couple graphs on the front we could do. You good? Okay. Are you sure on the reflections homework there is nothing that we need to look at? Do you want to do a couple of these? Any ones you want to see? Now's your opportunity. Huh? Number 4? Mm-hmm. Okay. So let's look at number 4. I totally thought I had it in here, but apparently I don't. Okay, and I'm not even sure I would know where to find it. So let me do it this way.